Now let's talk about inserting a value into a sorted linked list. Just to go over briefly what exactly a linked list is, it's essentially a list of values that are object-based and are controlled by pointers. The three major components of a linked list are the head, the nodes that actually consist of a list itself, and a tail. And the nodes are where the values are stored of a linked list. If you see in this picture, we see the values 2, 4, 6, and 8 are stored as values in the node. What if we want to insert node 5 into our list? Our strategy is going to look something like this. You're going to begin by traversing a linked list starting from the head, and you keep on going until you encounter the first value greater than the value you wish to insert. If you look at the diagram over here, essentially you're starting from the head, and then you check 2 and 5. 2 is less than 5, so you keep on going. And so you move on to the next node, which is 4. 4 is less than 5, and so then you also keep on going. And then in this case, 6 is greater than 5, so we know that the node 5 has to go before the node with value 6. So we keep track of that information. And then after that traversal, when we hit the tail of our linked list, we're going to set the child pointer of 5 to 6, because we want the node with value 5 to direct us to the node with value 6. And then in turn, we change the child of the node with value 4 to our new node, which has a value 5. And we're done. Just going over what the code would look like for this. This first if statement checks basically two things. One, it checks to see if our linked list is empty or not, or if it checks that node insert, which is our new node, has a value less than or equal to the head. This either checks if our linked list is empty, or if the value we wish to insert is the smallest value out of our entire linked list. In that case, we would just put it at the beginning of a linked list. Otherwise, use a while loop to determine where exactly to put your new node. The while loop checks two conditions. If you're currently at a node that isn't the tail, and you also check to see if the current value is less than the value you wish to insert. And so while that happens, you're essentially moving cur, which is your current node, forward. And you keep on moving that forward until you break out of this loop, in which case you can then set the pointers appropriately by inserting your new node's child to cur, which has value greater than insert.value, and you also set the previous node's child to insert. And that's how our method is going to look for this.